Hello and welcome to yet another installment of the Algebra 1 videos. This is Unit 3 and this is Section 3, solving linear equations using the distributive property. So our objectives today, we want to solve one variable linear equations involving the distributive property. We want to determine if a one variable linear equation has 0, 1, or infinite solutions. And we want to create one variable linear equation solving using the distributive property to model and solve problems. So first things first, let's kind of look at some steps on how to do this. We always want to use the distributive property if we can, and then we combine like terms, and we want to isolate the variable and solve for what we're looking for. So here's what we've got. We've got this problem here, and this one is 15x over 2 plus 5 is equal to 5/6 times 12x minus 6. And the first thing I want to do is I notice that I have a number that I am multiplying that's on the outside of the parentheses of this term here, 12x minus 6. So what I want to do is I want to multiply each of those through and evaluate, okay? And so let's go ahead and write our next step, which is going to be 15x over 2 plus 5. And that's going to equal 5/6 times 12 over 1 times x, and then minus 5/6 times 6 over 1. Okay, now one of the things that you guys can do, it kind of depends on how you see this, but, on this left side of the equation, I'm just going to rewrite it for my next step. I'm just going to write 15x over 2 plus 5, and then when I have this, when I have 5/6 times 12 over 1, I can do 5 times 12, which gives me 60, and then divide it by 6 times 1. So 60 divided by 6 is going to be 10x, okay? However, what I could do instead was I could look and say that, well, if I take 12 and divide it by 6, then that divides out to 2 over 1. So what happens is I actually kind of get rid of my fraction, and I end up getting 5 times 2, so 5 over 1 times 2 over 1 times x, okay? And the same thing happens over here, okay? When I've got the 6 up here and the 6 down here, these 6's divide out to 1 over 1, okay? And so then I end up getting, minus 5 over 1 times 1 over 1, okay? And I'm showing a lot of steps here just because I want you guys to see how I'm getting my answers and not just a trick on how to do this. But let's go ahead and simplify this a little bit. And so then I get 5 times 2, which is going to be 10, and then 1 times 1. Okay, so I don't really need those. I'm really just doing 5 times 2 right here. So that's going to give me 10x, and then minus 5 over 1 times 1 over 1. That's just going to be minus 5. Okay, and then on the left side, I've got 15x over 2 plus 5. So now that I've done the distributive property, and it kind of, because we're using fractions, it's going to require a lot more steps. What I want to do is I want to get all the variables on one side of the equal sign and all the variables on the other. So what I'm going to do first, and it doesn't matter what I do, but I'm going to get all my x's on the left side of the equal sign and all my numbers on the right. So the first thing I'm going to do is subtract 10x from both sides, so minus 10x, okay? And as a result, here's what we get, okay? I'm going to get negative 10 over 1 times x plus 15 halves times x plus 5, and that's equal to negative 5, all right? Now, in order to combine these, I got to get like terms, okay? Or I got to get, these are like terms, I just need to get a common denominator. So I'm going to multiply the top and the bottom by 2, okay, to get a common denominator of 2. And let's do this up here. And we've got, that's negative 20x over 2. So I've got negative 20 over 2x, and then plus 15 over 2 times x. And then we've got a plus 5. Okay, and that's equal to negative 5. Okay, now what I can do is I can combine these two as like terms, okay, and I'm just going to add my numerators, okay, and keep my denominator of 2. So negative 20 plus 15 is really going to give us negative 5 halves x plus 5, and that's equal to negative 5, okay, and I'm going to go ahead and subtract 5 from both sides, Okay, get all my numbers on the right side. So I've got negative 5 halves x, and that's equal to negative 10. Okay, I'm then going to, I'd like to divide by this number, negative 5 halves, but algebraically, I don't know how to do that. So I have to, when I have a fraction like this, I have to multiply by its reciprocal. So I'm going to multiply by negative 2 over 5. And then here I'm going to do times negative 2 over 5. And I'm going to put this negative 10, I'm going to put that over 1. Okay? So then what happens here is that these 5s divide out, the 2s divide out, and you're just left with x. Okay? And then, it kind of depends how you want to look at it. You can just multiply this across. Negative 10 times negative 2 gives you positive 20. 1 times 5 gives you 5, so you've got 20 divided by 5, which is going to give you 4. Okay? So you get this value of x is equal to 4, and that's the answer that we're looking for. All right? So that's it. All right. Let's go ahead and take a look at the next one. Similar type of problem. Let's go ahead and solve this for x. Now, the first thing I notice, guys, is that I can distribute this 3/5 into x minus 10, okay? And so let's go ahead and distribute that 3/5 in there. So then we get this. We get 3/5 times x minus 3/5 times 10 over 1. Okay, and then this is equal to 18 minus 4x minus 1. Okay, now I'm going to simplify this over here. And you could do this a couple different ways, but I've got 3 times 10, which is going to give me 30 divided by 5. So this is really going to be just 7. Okay, so I've got 3/5 x minus, no, that's not 7, that's going to be 6. So I've got 3 times 10, which is 30. Divide that by 5, which is 6. So I've got minus 6. And then this is equal to, and let's go ahead and combine the 18 minus 1. Okay, and that's going to give us 17. So I've got 17 minus 4x. Okay, now what I want to do is, and you can do a number of things here, but I'm going to go ahead and add my 4x. I'm going to get all my x's on the left side. So add 4x to both sides. So on my next step, I've got 4 over 1 times x plus 3 over 5 times x minus 6, and that's all equal to 17. Okay, now I need to get a common denominator of 5. So I'm going to multiply this by 5 on the top, 5 on the bottom. And so as a result, we get 20 over 5 times x plus 3/5 x minus 6 is equal to 17. So then, okay, I want to combine the 20 and the 3, keep my denominator of 5. So this is going to give me 23/5 x minus 6, and that's equal to 17. Okay, now I'm going to add 6 to both sides, okay? And therefore, okay, at that point, let me do this up over here. This is going to give me 23/5 x, and then 17 plus 6, that's, what is that, 23? Oh, yeah. And that's going to equal 23. Okay, so now what I want to do, and let me rewrite this so I've got some space to work. 23/5 x is equal to 23. Okay, now to divide by 23/5, that's the same thing as multiplying by the reciprocal. Okay, 5 over 23. And I'm going to put this 23 over 1 and multiply it by 5 over 23. Okay. So what happens is that the 23s divide out, the 5s divide out. You are simply just left with x, and then this is equal to, now over here, the 23s divide out to 1 over 1. Okay, so I can cross those out, and I'm just left with x is equal to 5 over 1, which is just 5. Okay, so, not too terrible, but, we just got to make sure that we're, doing every step and getting common denominators and all that. Okay, let's take a look at another one. Okay, solve this equation. Now we've got to do the distributive property twice. Okay, every time I've got this a number on the outside of a parentheses and there's no other operation on the inside, that means I got to distribute. Now with this, we have to distribute the negative. Okay, so I'm going to do negative 3 times x and then negative 3 times 2.7. So my next step is going to be 4.5 minus 3 times x minus 3 times 2.7. Okay, and I'm going to do the same thing on the other side. Distribute the 7 to here and to here. All right, So that's going to give me 7 times 8.1, and then minus 7 times 4x. So let's do a little bit of arithmetic here, friends. So this is going to give me 4.5 minus 3x, and then negative 3 times 2.7 is negative 8.1, okay? And then if I do 8.1 times 7, okay, that's going to give me 56.7, okay, and then minus 28x, okay? Now what I can do here is I've got a number here and a number here. I can combine those as like terms. So if I do 4.5 minus 8.1, that's going to give me negative 3.6. So let me do negative 3.6 minus 3x is equal to 56.7 minus 28x, okay? Now, you can do a number of things here. I'm just going to go ahead and move on my x's on the left side. So the first thing I want to do is I want to add 28x, okay? And add 28x. And so I get negative 3.6. Okay, negative 3x plus 28x gives me positive 25x. And this is equal to 56.7. Okay, and then I'm going to add 3.6 to both sides. So add 3.6 to both sides. All right, let me make some room over here. We end up getting that this is 25x. And then this is equal to 56.7 plus 3.6 is going to give me 60.3. So this is 60.3. And then I want to divide everything by 25. Divide everything by 25. So I get x is equal to, what is that? 2.412. Okay. And that's it. That's our answer. All right. And that's what our value for x is. Okay, so same thing, guys. I'm not doing anything different than I was up here. It's just I'm not dealing with fractions. I'm dealing with decimals. Okay, on this last one, okay, let's do this one real quick. I still need to distribute my negative 2 here into x and then 7. And then I'm going to distribute my 3 into x and 5. So I've got 4 minus 2 times x minus 2 times 7. And that's equal to 3 times x plus 15, okay? So now, all right, let's evaluate some of this. I've got 4 minus 2x minus 14, and that's equal to 3x plus 15, okay? Now 4 minus 14, that's going to give me negative 10. So I've got negative 10 minus 2x is equal to 3x plus 15. Okay, now I'm going to go ahead and just add 2x to both sides. I'm going to move it to the right side. Okay, it doesn't matter which side you move it to. And that's going to give me negative 10 is equal to 5x plus 15. Now I'm going to go ahead and subtract 15 from both sides. All right, and that's going to give me negative 25 is equal to 5x. And if I divide both sides by 5 and by 5, then x is going to equal negative 5. Now, this is one that we should hopefully be able to do because it doesn't have any fractions in it, okay? So, but either way, we've just got these steps. We've got to clear out the distributive property and then, just solve any equation like we normally would. So, okay. Okay, on this one, it wants us to take a look to see what types of equations we can get from solving equations. All right, so, we get this thing where it says always true, sometimes true, never true. And so what I want to do is go through these 3 examples and show you guys how, we get these types of, equations and solutions. So let's take a look and see how we would get one solution. And this is just when you solve an equation like you normally would, then you can, you just get one value for x, all right? So if I multiply out this 4, and so I'm going to get 4x plus 8 is equal to 16. Okay, I want to subtract 8 from both sides, and we'd get 4x is equal to 8. And then divide by 4, and so we get that x is equal to 2. Okay, pretty easy question to do, pretty simple. But this is just one solution. Okay, this is where we just get one value for x. Okay, and this is typically what's going to happen, but sometimes you might get something weird like this, where you get infinitely many solutions. Now, what I would do here is just solve this thing like I normally would and do 2 times x and 2 times negative 5. So if I distribute that 2, then we get 2x minus 2 times negative 5 is 10, so minus 10. And that's equal to 2x minus 10. Now what I want you to see is that I have the same thing on the left side as I do on the right side. So anything I plug in for x over here, I'd have to plug in over here, and this would always be true. Okay, and that's how you get infinitely many solutions. You know, I can plug in 1 here and 1 here, and if I evaluate this, I'll get the same thing over here as I did on the right side. Okay, so what I want to do is, to show you how you can tell. So if I were to add 10 to both sides, and then this is going to cancel out. Okay, and it's going to go to 0. And then if I take negative 10 plus 10, that's also going to give me 0. So I end up getting the value of 2x is equal to 2x, okay? And if I were, again, you're getting the same thing on the left side as you are on the right side, all right? But if I were to say subtract 2x from both sides and combine my like terms, then I would end up getting that, 2x minus 2x, that becomes 0, okay? And then here I get 2x minus 2x, which also becomes 0. Now, when I have the statement that 0 is equal to 0, that is a true statement, okay? Because that is a true statement, okay, any value that I plug in for x in any of these parts up here, I'm going to get a true statement. I'm going to get that something equals something else, okay? And so therefore, I can plug in any x value and get the same thing as I would on the left side as I would on the right. So I can plug in any x value. That means I have an infinite amount of solutions. Infinite solutions. Okay? I wish my life had infinite solutions. Unfortunately, it's finite. I don't have that many solutions for all my problems. Okay, anyway, let's look at an example where it says no possible solutions. So what would happen here is I would still distribute my negative 3 inside the parentheses, and this would give me negative 3x minus 9, and then I get negative 3x minus 11. Notice that I have the same term here, negative 3x, as I do on the right side. Okay, this is kind of the tip-off. Now what I would do is I would add 3x to both sides, okay, and combine my like terms. But what's going to happen is that these are going to add to 0. And so is it going to add to 0 here. So as a result, because those add to 0, I'm left with negative 9 is equal to negative 11. Now, folks, this is a false statement, okay? There are no numbers that I can plug. The negative 9 is not equivalent to negative 11. Therefore, it is false. Now, if it is false and you get a false statement, then you know that you get no solutions, okay? And that's it. That's what we're doing. So if you get, x equals a number, you have one solution. If you solve an equation and you get a true statement, you have infinite solutions. But if you solve and you get a false statement, then you get no solutions, okay? And that's it, all right? Now let's go ahead and do, let's answer this question. Let's solve this one. So here I would distribute my 3/5 into, multiply it by 5, multiply it by negative 15x. Here I'm going to multiply my 9 through, and let's see what we get, okay? So if I take 3/5 times 5 over 1, okay, minus 3/5 times 15 over 1 times x, okay? And then over here, let me do 9 over 1 times 1 over 3, and then minus 9 times x. Okay, now, what I can do is I can start dividing things out. The 5 divided by 5 divides out, and that leaves me with 3 divided by 1, which is just 3, okay? Now, over here, okay, I've got 15 divided by 5. That's going to be 3 over 1, okay? And so then the numbers that I'm multiplying, I'm going to multiply negative 3 times 3, which gives me a minus 9, okay? And then 1 times 1, those just go away. So I get minus 9x, okay? And then over here, okay, I get 9 divided by 3, okay, which divides out to 3 over 1. So 3 times 1 over 1 times 1 is just going to be 3, so I get 3, and then minus a 9x. Now notice that I have the same thing on the left side as I do on the right side. Okay, so this is going to be infinite solutions, but let's go ahead and let's evaluate this. Let me add 9x to both sides. Okay, and when I do that, negative 9x plus 9x, this goes away and cancels out. Same thing over here. When I take negative 9x and add 9x to it, it adds to 0, and they cancel out. So therefore, I'm left with 3 is equal to 3. Now, okay, I've gotten rid of my variables, and I've got a true statement. So if I have a true statement, then I know that I have an infinite number of solutions. Infinite solutions. Okay? Not to be confused with my personal life, which has a lot of problems in it, and I digress. Okay, now let's take a look at this one. So what I want to do on this one, I want to multiply through the 1/7, and so I'm going to just, let me zoom in real quick so we're a little bit better. Okay, I'm going to multiply by 1/7 through and through. So I've got 1/7 times 14 over 1 minus 1/7 times 7 over 1 times x. Okay, and then this is equal to 5. I'm going to do the same thing over here. I got to distribute my 5 into here, into here. So I'm going to do 5 over 1 times 7 over 10. Okay? And then I'm going to do minus 5 over 1 times 1 over 5 times x. All right, so now let's see what we can get here. So the 1/7 times 14 over 1, the 14 divided by 7, that's going to divide out to 2 over 1. Okay, so you're left with 2 minus, okay, I've got 1/7 times 7 over 1. The 7 divided by 7, that divides out to 1 over 1. Okay, and when all that divides out, you're just left with x, so minus an x. Okay, and then this is equal to, all right, I can divide out the 5 and the 10 into 1 divided by 2. Okay, so that really just leaves me with 7 halves. All right, and then, okay, I've got 5 divided by 5, which those divide out to 1. Okay, 1 over 1, so you're just left with a minus x. Okay, now notice that I have the same minus x on the left as I do on the right. Okay, and I've got the 2 and then the 7 halves. So this is going to be no solutions. So let's take a look. Let's go ahead and add an x to both sides. Okay, and let's see what happens here. So then we get that 2, okay, because negative x plus an x, that divides out, or that just adds to 0, so it cancels. Same thing over here on the right side, it cancels out. So then we're left with 2 is equal to 7 halves, okay, and because these are not the same number, this is a false statement, which means that there are no solutions. Okay? No solutions. All right. Okay, on this one I'm kind of running out of time. We will work on something like this in class. Okay, I will go over this in class, so we are all kind of on the same page with it, but we're kind of running out of time. So go ahead and get started on the assignment and then the quiz. Thank you. See ya. Bye.